Hello everyone and welcome to another video with Mr. M. Today's topic is motion graphs, something quite important in the topic of kinematics in physics and something that many of the students struggle with. So I hope by the end of this video you will have a better idea of how to draw and how to interpret motion graphs. This should probably be at least 2 or 3 videos, as this is a quite extensive topic. But let's get right to it. So motion graphs, mainly we'll be discussing 3 different types. We'll be discussing the distance time, speed time, and acceleration time graphs. Depending on your high school level, you might see it as displacement time, velocity time, and acceleration time as well. We will mention the differences as we go through the video. Make sure if you have any questions or comments that you like sharing with the rest of the community, put them in the comment section below and I'll be happily answer those. Now, before we dive into the physics part of it, we need to discuss a mathematical concept, something that hopefully most of you have already encountered in your math classes, and it has to do with slope or gradient, and something that in your math classes you have defined with the letter M. And on a simple graph, okay, that looks like the one I have drawn here, with some values on the y-axis and some random values on the x-axis, we have different lines and curves, and you have defined the gradient as the rise over run, or in other words, as the y value over the x value, this ratio. Now, in terms of how positive or negative, or when this value is 0, I have designed this extra part here, okay, which I hope will help you. So for instance, you can see that the steeper the line, the more positive it gets, okay, and that's, let's say, in scenario 1. Then in scenario 2 we have a less positive gradient. Scenario 3 is a flat line, which is 0 gradient. Then scenario 4 is a less negative, and 5 a more negative gradient. Okay, this would be quite important because, as we will see soon, gradient represents something specific in all these graphs, and you should be able to compare these different gradients in the motion graphs that we'll see in the examples later on. So if you look at the red line, okay, and you want to define the gradient for the red line, it's the rise over run, or in other words, it's the length of this side over the length of this side, and it's 2 over 2, so that's 1. The gradient of the orange line, as well as the gradient of the purple line, as you can see, it's a flat line, which means the gradient is 0. Now, when it comes to the gradient of a curve, okay, so the green line and the blue line, in this case, we are interested in defining the gradient at a specific point, okay? So let's say if I want to know the gradient at this point, I would have to draw the tangent, okay, the tangent line at this point, and this would help me define the gradient at this point. This will become much clearer once we dive into some examples. I hope this is clear. And just a reminder, something that we have seen in our previous videos, and if you haven't watched them, make sure you go into the channel and check our videos about velocity and acceleration. We defined velocity as the change in position or displacement over change in time, and acceleration as the change in velocity over change in time. So these two are quite crucial for the upcoming slides. So the first example I have here and I'm discussing is the distance time graph. Okay, so I have drawn different sets of lines and curves, and we'll go step by step and try to interpret them based on what we discussed on this slide, which you should always come back to whenever you don't exactly remember what the gradient means and how it looks like on a y-x graph. So let's look again. This is a distance time graph. My tip to all of my students is that whenever you see a motion graph, the first thing you should do is look at which variable you have on the y-axis. Is it distance? Is it speed? Is it acceleration? Because this completely changes the game of your analysis, okay? So on the y-axis we have distance, on the x-axis we have time, and we have the red line, okay? So from 0 to t1, which is a random moment in time, we see that the gradient, okay, if you were to define it, it will be the rise over run, okay? The gradient is not changing, the gradient is constant, okay? And we should know that the slope, the gradient in a distance time graph will give us speed, okay? Why? Because we define speed and velocity as change in position or change or the distance traveled over the time, okay? So this ratio, okay, or in other words, the slope that you see here on a distance time graph, okay, because this side here is the distance that you see on this side, and the x value represents time, okay? So the slope in a distance time graph gives you information about the speed. So the slope is not changing, which means the slope is constant. So I have a constant velocity, and the object is moving far away from the beginning point. The distance is increasing at a constant velocity. Now from t1 to t2, we see that the distance is the same, so it's not moving further away. And this makes sense because the line is a flat line, which means the slope is 0, which means the velocity is 0. In other words, we call it a stationary condition, so the object is not moving. Now if you look at the moment from t2 to t3, okay, we have this curved line, okay, and if you were to draw this the tangent for smaller moments between t2 and t3, you would see that the tangent keeps, if you do it at different points, keeps increasing more and more, okay, which shows you, okay, that the speed also increases, okay, so the object is speeding up, so we have, as we call it, a positive acceleration. Now the case in between t3 and t4 is exactly identical to the orange line, so it's a stationary condition with constant distance, which means 0 velocity, which means stationary. And then t4 and t5, it's the opposite of the green line. In this case, the gradient starts really high, okay, and then it always becomes less and less steep, which means we have a negative acceleration and the object will be slowing down. I hope this is clear for the distance time graph. Now moving on to the velocity time or speed time, again depending on from which angle you approach the problem. So from 0 to t1, as we can see, we have again a constant slope, a slope that is not changing. The slope in a velocity time graph gives you acceleration. Why? Because acceleration is defined as the change in velocity over change in time. So the y in this case will be the change in velocity, and the x is going to be the change in time. So the slope here is constant. Constant slope means on the velocity time graph, you see the first thing I identified was what do I have on the y-axis, and I have velocity. So in this case, acceleration will be constant. Now t1 to t2, velocity is constant. Constant velocity means 0 acceleration. If you don't have change in velocity, you cannot have acceleration. Or if you have a 0 slope, it means that your acceleration is also 0. So you have different ways to approach the problem. Now t2 to t3, we have again the same approach with the having to draw the tangent all the time, okay, and we can see that the tangent keeps increasing. So increasing tangent means that the acceleration keeps increasing, okay. Now t3 to t4 is another case as the orange, so constant velocity and 0 acceleration. And t4 to t5, again it's the opposite, where the slope keeps decreasing, which means, in other words, the acceleration keeps decreasing, okay. And now if we move on to the acceleration time graph, okay, so on the y-axis now we have acceleration. The slope in an acceleration time graph will give us a new quantity in physics, which we're not using that often on high school level, depending of course on the curriculum you are following, which we call jerk. So the rate of change of acceleration, it's a new quantity in physics, which for most of your programs you don't need to know. But let's see how the graph looks like. So if we look at the red line from 0 to t1, we see that the acceleration is increasing at a steady rate, and that's at a constant rate, and that's what our observation is about. Why? Because again, the slope is not changing. The slope is not changing. It means it increases at a constant rate. From t1 to t2, okay, and that's interesting, you have a constant acceleration. So acceleration is not changing, which means the velocity is increasing at a constant rate, okay? So if you look at the previous one, okay, you would have, let's say, the scenario of the red line. The velocity increases at a steady rate, which would mean that your acceleration is constant. So in this case, the red line of the velocity time graph would be equivalent to the orange line of the acceleration time graph, okay? By the way, this is not a one-to-one transformation of distance to velocity to acceleration time graph, which means the way the object is moving is not fully represented and transformed from one graph to the other, okay? So to avoid any confusions. And then in the time period between t2 and t3, we have again acceleration, which we can see if we look at the tangent again, which is going to be again, we said the jerk, okay? It keeps increasing at a changing rate. So acceleration is changing at not a constant rate, a positive one, and then in the last part it's changing at a negative one, okay? So that's all I wanted to say for this video, guys, okay? If I can quickly sum it up, I would say focus on understanding what slope means mathematically, so rise over run or y over x, okay? How you can explain how how one line behaves compared to another one, okay, in terms of how steep it is, okay? So which line is steeper than another one, what this, like the zero line, so the zero slope actually means and how it looks like. And then once you have identified and clarified the mathematical background, then you can give more context to it by moving into the physics problem. And again, I will repeat and highlight that the first thing you need to do in any exercise that has to do with motion graphs is identify what you have on the y-axis, which variable, and then what information you can get from this graph. From a distance time graph, the slope gives you speed. The velocity time graph, the slope gives you acceleration. And the acceleration time graph, the velocity gives you something that you should not be concerned with yet. I hope this video was helpful. Let me know if you have any questions. Write it down in the comments below. Don't hesitate, don't be afraid, and I'll be happily answering those questions. Till the next